Hello, everyone. So as Simon introduced me, I'm Amit. I'm the founder of Entropic Labs, a development firm within the Kujira ecosystem. And today I'll be talking a bit about how you can use the tools that exist on Kujira to build really powerful DeFi apps in the most simple way possible. Um, so just some background on me. Before all of this, I was at the Anchor team at Terra before joining the Kujira team for building out some of the core Kujira DeFi products, notably Ghost, among helping out with others. I went on to found Entropic Labs, which has now taken over the development of Unstake, which is an instant liquidity protocol, and then Quark, which is an interchain programmable yield protocol, all living on Kujira. Yeah, so just for some background on AwesomWasm, I'm sure you're all relatively familiar with AwesomWasm, but the contracts in AwesomWasm are structured as these actors, and the formal name for this is the actor model. So let's say I have on the right here some contract A. I can send and execute message to that contract, and that contract can emit one or more messages to follow-on contracts. It can emit nothing if it's a self-contained contract, but it can branch out to other contracts, for example, for more functionality that the other contracts provide. So for example, here we have these other subcontracts, not subcontracts, but later sub-messages that are called into other contracts, B and C. And for example, this might be B, an exchange, and then C, some sort of lending protocol. And this contract A might be tying them all together in some way. And we'll see how this all comes together later. Now, we also have the ability to use native blockchain APIs when we're making our AwesomWasm contracts. So the Cosmos SDK provides like a host of modules, and some of those, for example, are the bank module, the IBC module, the staking module, and so on. And we have the ability to easily call into our native Go modules via AwesomWasm to query these Go modules via AwesomWasm. So these contracts not only can call other contracts, but can change the blockchain state and the query these, like for example, staking balances, their bank balances, and so on. Yeah, so the big idea, if there's one thing you want to take away from this workshop, is that Kujira's native DeFi building blocks help you build your own DeFi apps really, really fast. So what I mean by DeFi building blocks, I'll run through a small subset of them very quickly, is we have our own protocols, many of which are self-contained in their own way. So for example, here we have Fin, which is a decentralized exchange. And Fin is special because it has a 100% on-chain order book. And Fin is self-contained in its own regard. You can trade on Fin. It has its own web app with all the pairs, I think probably closing 100 different pairs at this point. But from a technical standpoint, you can see we can basically enter Fin in three ways. We have the swap entry point, where we instantly swap an asset A for another asset B on that trading pair. And then given that Fin is an order book exchange, we can also submit and withdraw orders. And these orders may or may not be filled instantly. So for example, I submit an order for buying Bitcoin at a price of, I don't know, $60,000. And that price may or may not be hit. And if it is hit, my order will be filled. It might be partially filled if it's only hit for a certain amount of time. But I can also withdraw that order to cancel the order or to withdraw a partially or fully filled order. And the beauty of an fully on-chain order book is that we can kind of structure many, many different strategies on top of that order book. For example, the traditional constant product pool that we see in many exchanges like Uniswap and Osmosis and so on, that can be structured just as another trading strategy on top of Fin. But then because it's an order book, you can have like stable swaps, you can have trading strategies like grid bots and so on, all easily using this single interface, unified order book. And so what we've done is to demonstrate and to like actually take advantage of Fin is build an automated market maker, Bo, which has several different of these strategies. And Bo works pretty much directly on top of Fin. Users provide liquidity to Bo in the form of assets in like the A and B asset for that pair. And then Bo has, I think we have 2 or 3 different strategies on Bo right now, but the easiest one is just a constant product strategy where you have the XY equals K kind of formula uses to dictate how the assets are spread across the order book. And the idea with Bo is that it's an automated market maker on top of Fin, and users who are not active traders who don't run their own bots, but do have their own assets, they can just deposit into Bo, and Bo automatically kind of rebalances the orders and provides this very easy interface to earning revenue on your assets from trading fees. And we'll see later that because we have this very simple interface for just providing liquidity and withdrawing liquidity, we can actually build even more applications that utilize Fin indirectly via Bo. And then the kind of the original Kujira protocol was Orca. This existed way back in the Terra days. And Orca is a fair queue-based liquidation engine. And the beauty of Orca is that many of these DeFi protocols have positions that, for example, have margin, are leveraged in some way, and are using borrowed assets. And these DeFi protocols often have to worry about handling liquidations in their own ways. And liquidations are both a complicated thing to get right, but also have a lot of risk because they can create bad debt if done improperly. And the amazing part about Orca is that any external market, as you can see on the top there, all it has to do is send its assets to Orca, and it'll receive the returned liquidated assets kind of value back, and it can use that to repay a loan, or it can use that to make users whole in whatever way it pleases. On the user side, users can submit liquidation bids and withdraw their filled bids. But as we'll see, many of the protocols will benefit directly from the actual market side, liquidating their market assets on Orca. And then we have Kujira Ghost. Ghost is the modular lending market, and Ghost kind of has 2 sides to it. We have the vault side, in which you can deposit various assets and generate interest on your assets. And this is very simple for users. They deposit, for example, USDC into the Ghost vaults. And in return, they'll get basically this IOU token that shows that they own a share of the vault assets. And as other markets that plug into Ghost vaults borrow assets from Ghost and therefore pay interest on their borrowed assets, the lenders earn interest on their or not their collateral, on their assets. And the idea with Ghost is that we're separating out the vaults explicitly from markets because we can have several different types of markets that use Ghost in several different ways. So as we'll see here, the basic market is something that just borrows assets from Ghost and repays assets from the Ghost vaults. And all it does really is it intakes some collateral and allows users to borrow against that collateral. So it's the most simple type of loan. But we'll also see different types of markets which manage collateral in different ways, which represent positions as collateral and so on, which is why Ghost is structured already as this modular component within Kujira. So as we can see here, these markets actually plug into 2 different protocols, well, 2 different contracts. We have the markets plugging into Ghost for actually borrowing and repaying loans. But then for when a position starts to get unhealthy, so for example, I've taken out a loan against my Atom, and Atom's price has fallen by 20%, and my loan is reaching some unhealthy level. The market can liquidate my Atom collateral via Orca that we discussed earlier. And it will receive, for example, the USDC that it needs to repay partially or fully the loan that I took out against my Atom. And this is all very easily done via the components that already exist on Kujira. And then a common pattern that you can see here is that there's several different actions that are happening within this protocol. You have the position opening, which causes a borrow. You have the position closing, which causes a repay. You have liquidations, which causes a repay and a liquidation through Orca and so on. But the users are only exposed to like an open and a closed position. So we're kind of simplifying the interfaces and wrapping up all this functionality like in a really nice package that is minimal and really easy to use and plug into as other protocols even. So one thing I like to say is that building applications on Kujira is pretty much like building Legos. And this is something we've actually literally like taken to heart. We have all these components and sometimes we just see like, how can we fit these together? Like, is there anything that, any interesting behavior that comes out of fitting anything together that we already have? As we'll see, this is like something that really already exists and we've taken advantage of to build our own very interesting protocols. The first case study I want to go over is margin trading. So just for some background, margin trading is the concept where a user who has, let's say, $100 worth of buying power has like very strong conviction on the price of some asset going up or down. And let's say that they're betting that the price of Bitcoin goes up by 10x. And they buy $100 worth of Bitcoin expecting the price to go up by 10x. When the price, let's say, does go up by 10x, they'll have $1,000 worth of Bitcoin. But since they started off with 100, their profit is only $900. And let's say they're very, very confident in this bet. So they want to take out a loan and buy more Bitcoin. And the idea here is that let's say the user takes out another $100 loan. Now they've bought $200 worth of Bitcoin, which is worth $2,000 after everything is said and done. And the profit and loss there is they've started with $100, they've taken a debt of $100, but they've ended up with $2,000. So they've made $1,800 off the same trade. And so obviously, with bigger market movements with the user, you're making bigger profits. But then with when the market moves against the user, so let's say the price of Bitcoin falls, then the user is out of luck. And because they've used margin, the possibility there is that they lose much more of their initial investment than they would have if they just used a normal trade. However, we do want to enable this functionality because it gives users, more choice, gives them the ability to represent their convictions much more freely on chain. And it also brings us much closer to having a centralized exchange like trading experience on a decentralized exchange, which is something that we're beginning to see, especially on derivatives exchanges like Vertex and DYDX and so on, when you're dealing with high leverage trading on synthetic assets. But then now we're also enabling this on spot markets. So the way that we want to implement margin trading is obviously on top of the exchange. So in this case, we're taking Fin. But then we also need to borrow assets to actually enable the margin to be borrowed and put into Fin as an order, as a swap, or whatever, what have you. So to glue this all together, we'll create this margin contract. And what this margin contract will do first is it'll borrow some amount of margin specified by the user from the Ghost Vault. And then it'll place the initial investment plus the margin borrowed as a order or perhaps as a direct swap on the Fin exchange. And then should the position get unhealthy because the price moves against the user, it'll plug into Orca as well to liquidate the collateral. And this whole thing is really just taking 2 or 3 of these building blocks, creating a contract that ties them all together, and then exposing a really simple interface to the user. Just saying, if you want to open a trade, how much margin do you want to take out? If you want to close a trade, how do you want to do it? Do you want to swap instantly to close a trade? Do you want to place a limit order? And then finally, in case the position gets unhealthy, it allows anyone to liquidate unhealthy positions. And so this is pretty much like a perfect example of how you can tie in 3 different protocols here, including Fin, to provide this this extended functionality that isn't really easily possible. So if I was building this from scratch, suddenly I have to worry about, do I have to implement an exchange from scratch? Do I have to worry about like how do I allow other users to lend assets so that I can borrow them for margin trading. How do I deal with liquidations? I have to create like a in-house liquidation platform and liquidation bots. All of that is basically taken care of for you. By what already exists on Kujira. And the beauty is that because you're plugging into existing apps, these apps have liquidity, they have users, so you don't have to worry about, for example, will the exchange have enough volume to support my margin trading platform? Will the money market have enough liquidity to actually let me borrow enough assets? Or will, most importantly, will the liquidation engine actually be able to support unhealthy positions should that occur, and should like a large position become unhealthy. The second case study is a lot more complicated. This is probably one of the most complicated protocols that exists on Kujira right now, and this is live on mainnet already. It's leveraged liquidity pools. And what basically we want to accomplish with this is, let's say we have someone who wants to provide assets to generate trading revenue on the Atom USDC pair. Then if they only have one of the assets, let's say they only have USDC and they don't have Atom, but they still want to generate revenue from this pair, they still want to basically, sorry, they still want to take advantage of what they think is like volatility on that pair and various like revenue generation strategies from that pair. They can provide just their USDC and they can borrow the Atom portion and provide that as like a single-sided liquidity providing strategy. Or if they want to provide much more liquidity than the assets they have, they can borrow both sides of the pair against some smaller initial value and provide with much more liquidity than they actually had in the first place. So this is the second use case is very helpful because we allow the user to basically provide much more liquidity at the same time because of how the liquidity traditionally works in, for example, constant product pools. The user is only really exposed to the impermanent loss risk, which talk to me later. We can talk about how that actually works out, or talk to Hans over there. But we're basically providing some risk minimized yield strategies using this leveraged LP as a primitive. And so what we want to do realistically is have this contract that borrows two different assets, one for the base and the quote of the pair, right? If you have a trading pair, you have two like A asset and a B asset. So we're actually plugging now into two different ghost vaults. And at the same time, we're using the initial user-provided liquidity plus the Ghost Vault borrowed liquidity to deposit liquidity into Bo, which in the background, as we mentioned, uses Fin to place its trades to generate revenue and so on. And then our positions consist of these LP tokens that are returned from Bo. And should these positions become unsafe, let's say because the user took out a single-sided loan and the asset they took a loan against is rising in value, then we need to liquidate the position. And then comes in Orca again. And Orca, here we have two different assets that we could liquidate and two different assets that we could borrow. Therefore, we need two different Orca liquidation queues that we plug into, one for the A asset and one for the B asset. And all of this functionality is tied together by this single levered LP contract that we're using. And as you can see, we're kind of like, taking all these existing building blocks and just like stacking them together and making this levered LP contract. And to the user, it's really like still relatively simple, right? You create a position by providing some initial amount of liquidity and by specifying like, hey, I want to borrow like 100 of the B asset, or I want to borrow like 50-50 of the A and the B asset. The user can adjust their positions at any time or close their position entirely to recoup or like realize gains, whatever it may be. And then, should a position become unhealthy, we can trigger the liquidation as we did in the margin trading contract. So, if you have any questions about these two case studies, feel free to come ask me or any of our mentors really about how how these things kind of string together. And then we have some other tools. So we have Pond, which is, I think Christian is right there. He's the guy who developed Pond. And Pond is basically a local development scaffolding environment for having Kujira chains, any like IBC tests you want, automatically building with these building blocks. I can actually show you a quick example of this. So here in Pond, we basically initialize a Kujira chain, and we once we initialize it, it automatically has a list of these contracts that are automatically deployed. So for example, we have several bow pairs, we have some ghost vaults, we have Orca, we have USK, which is our in-house stablecoin, and we have various fin pairs. And this is all created like within a span of like 10, 15 seconds for you on your local environment. So that's Pond. We also have various chain modules that are used, that are accessible by our AwesomWasm contracts. We have interchain account support, which is has been touched on, I think, by the previous talk as well, where a contract can control accounts on other IBC connected chains. We have very actually importantly native Oracle support. So what this means is that any contract that wants to plug into real-time asset price feeds can do so using a variety of different assets that are supported on Kujira. And these prices are supported by our Kujira validators. So we have 75 nodes running the blockchain. Each of these is submitting Oracle prices, and each of them is supporting the Oracle basically with a different price fetching strategy, so that we have a lot of kind of resilience to random price spikes, and we have much less likelihood of Oracle-based attacks succeeding. And all you have to do as a contract developer really is like write a line of code to fetch the Oracle price for a certain asset, and it's really easy. It's honestly amazing. And then finally, we have an on-chain scheduler available to contracts. So basically, what this is basically a cron job, where you can say, execute my contract every 100 blocks, or execute my contract like every day, once a day. And this can be used for example, cranking a contract that needs regular interaction, or for making sure that a contract is triggered once per day or once per hour, for example, for converting assets and so on. Yeah, so we have a Notion page constructed by JP here for pretty much everything you need to get started with Kujira development here. We also created a quick Telegram chat that has most of our Kujira mentors here in case you want to ask questions. And then if you want, you can message me directly on that chat or on Twitter. You have my Twitter handle, or sorry, X now. You have my handle right there. Yeah, I think that covers everything. Cool. Yeah.